10.8 is on roots of monomials. Reminder, monomials can be numbers such as 9a or 9a. These are all examples of monomials. So it could be a numeric value, a variable, or it could be the product of a number and a variable. What you're going to do today is simplify these using the cube root and the square root. So an example for square root, let's say we know that the square root of 9, we already know that is 3. So basically what happens here is if you break it down using prime factorization, inside your square root we know 3 times 3 gives you 9. Well, inside a square root, so if something is squared, if you have two terms inside that square root, you can move it to the outside, giving you 3. So we'll check out a few other examples here. In example 1, I always think it's easiest to go ahead and write this out, so I like to go ahead and prime factorization. I know you're going to find shortcuts along the way, but here's your square root. Inside your square root you have a 9, which is basically 3 times 3. You have k to the 4th power. K to the 4th power is telling you how many times you write out k. Well, that would be 4 times because it is k to the 4th power. So basically, inside your square root, you're looking for pairs. Since it is a square root, remember square root, we want pairs of 2. So here's a pair of 2. I like to go ahead and circle them so you can move this to the outside, so you're left with a 3 on the outside. Here's a pair of k's. I can move a k to the outside, and then another pair of k's, so you can move another k to the outside, which would basically give us 3k to the 2nd power. Example 2, simplify 400w to the 8th x to the 2nd. Some of you might know what the square root of 400 is. You can already probably pull out a number out of that because it is a perfect square. But if not, you could do your prime factorization. So prime factorize everything. We know that a 2 can go into 400. So I'm going to go ahead and write a 2 down. Here's a 2. When you divide 2 into the 400, you're left with 200 left. So another 2 can go into it, which is down to 100. So another 2 can go into it, which is down to 50. Another 2 can go into it. And now you're left with 25. Well, to get to 25, you'd multiply by 5 twice. Now, if you multiplied all those numbers together, you would find out that it would give you 400. The next step is it tells you how many w's you have. Well, this says w to the 8th power. So I'd have 8 w's. There's my 8 w's. Next, it would tell me that we have 2 x's. So I'm going to go ahead and fill in my 2 x's inside my square root. Now, this is again talking about a square root. Square meaning 2. It takes 2 to move something out. So I group them in groups of 2. Here's another 2 I can move out. Here's a 5 I can move out. Okay, I have a group of w's. There's one group of w's. Second group, third group, fourth group. So I can move 4 w's out. And then I have a group of x's that I can move out. Now when I multiply everything here, I have 2 times 2 is 4, times 5 is 20. So I have 20 w to the 4th power, because there's 4 w's, x. Now, shortcuts that you can take when you get in here, many of you know that the square root of 400, it is 20. So if you know that, you can go right ahead and take that and simplify it right away. If you don't, you're going to have to list some of these off and then pull terms out. That's the best way, easiest way to simplify things. Example 3, we jump into something else. This is called a cube root. Look at how we have a cube on the outside. So in a cube root, cube is 3. It's going to take 3 things to move something out. So for example, you have the cube root of a to the 6th power, and you can easily put some of these in your calculator. For instance, if you have the cube root of 27, right? So what times what times what would give me 27 is basically for cube root. Well, I'd have 3 times 3 times 3. 3 of them, I get to move one out. That would give me 3. and you can figure out how to use cube root on your calculator as well. So in example 3, we don't have a numeric value. We have an algebraic variable up there. So this is going to be, again, cube root. I'm going ahead and break down a to the 6. So I have 6 a's inside my cube root. Cube root is telling me I need 3 in order to move one out. So I'll move this guy out. There's an a group of a's. Here's a group of a's. So I have a times a, which would give me a to the second power. So the cube root of a to the 6 is a to the second power. Cube root of 343, m to the 12th power. I'm going to go ahead and start again by breaking down using prime numbers to factor out a 343. I know 343 is not divisible by 2, 3, 4, 5, 6. So I'm going to go ahead and put in 343 in my calculator and see if it's divisible by 7. And actually I do find out that it is divisible by 7. So when I divide 343 by 7, I get 49. You can break 49 down again. 49 is 7 times 7. So 343 is 7 times 7 times 7. Then we have m to the 12th power that I'm going to take care of. And this is basically saying that, hey, I have 12 m's. So I'm going to go ahead and list off 12 m's inside my cube root. There they are. Everything prime factorization right there. Again, we're talking about a cube root. Cube root is telling us I need 3 in order to move something out. So here's a set of 3's. I can move a 7 out. Set of m's. There's one set of m's. There's 2 sets of m's. There's 3 sets of m's. And 4 sets of m's, which means I can move 4 m's on the outside of the cube root here. When I multiply everything together, I have 7m to the 4th power. So the cube root of 343 m to the 12th is 7m to the 4th power. Example 5, throwing a little geometry at you. It says find the length of one side of a cube whose volume is 729 g to the 18th cubic units. So we're doing volume of a cube. One thing that we know about a cube is all side lengths are the same. So the volume of a cube is length times width times height, and they're all the same. So to figure this out, you're going to use the cube root of your volume. So cube root, because you're dealing with volume, we know all side lengths of a cube are the same length, and that's basically what cube root deals with. So we have 729 g to the 18th power in the cube root. We'll break everything down. In this problem, I know 729 is divisible by 9. And if you don't see that, that is not a big deal. So you can test out 3. Okay, you can say that it's divisible by 3 if you're doing prime factorization. So 729, if you have it in your calculator, divide it by 3. When you divide it by 3, put 3 inside that cube root. Now you have 243 on your calculator. That is divisible by 3 again. So I'm going to put a 3 down. Now I'm at 81. Well, 81 is 9 times 9. Well, 9 times 9, if I write it like this, is basically going to give me, we know 1 9 here, is going to give me 3 times 3, right? So 3 times 3. The second 9 is going to give me 3 times 3. So if I multiply all those together here, you would wind up with 729. Basically, if you look at it this way, there's a 9, there's a 9, there's a 9. So 9 times 9 times 9 is going to give you 729. Now you have g to the 18th, so there's 18 g's. Here's what it would look like inside that square root with 18 g's. Now we're talking about cube root. Cube root means I need to have a group of 3. Well, there's one group of 3. There's a second group of 3. So I can move a 3 out and another 3. Figure out how many groups of g's I can move out. There's a set of 3. There's 1, 2, 3, 4, 5, 6 groups. So if I move 6 out, I have g to the 6th power. So my answer is 9g to the 6th power. Each side length is 9g to the 6th power. And you could check that out by simply putting in for length, width, and height, and you would wind up with 729g to the 18th if I multiplied 9g to the 6th power 3 times. 6, geometry. This time you're going to go ahead and use a square. So you're trying to figure out the length of a square whose area is 121 x to the 14th. So here's your square. The area is 121 x to the 14th, and you're trying to figure out the side length of each side. Well, we know squares have the same side length. So to figure out area, well, if you think area, it's unit squared. What gets rid of a square is square root. So when you take 121 x to the 14th power and put that in a square root, break everything down, well, 121 we know is divisible by 11, so it is 11 times 11. You have 14 x's in there, so I'm going to go ahead and put 14 x's down. There's what we'd have inside that square root. Square root. Square. Okay? You need 2 of the same in order to move it out. So there's a pair. There's 1, so I can move an 11 out. And now I figure out how many groups of x's. There's 1, 2, 3, 4, 5, 6, and 7 x's. So I have x to the 7th power. So each side length here is 11x to the 2nd power. And a way to double check that as well, 11x to the 7th, 11x to the 7th, 11 times 11 is 121. X to the 7th times x to the 7th is x to the 14th. So check out. This will conclude 10.8 Roots of Monomials.